Welcome everyone to our sixth episode in our 2018 Washington State Energy Code training series. My name is Duane Lewellen and I'll be your host today. The primary topic we'll be covering is key changes to the surface water heating and refrigeration requirements in the 2018 Washington State Energy Code. Before we get started, let's cover a few housekeeping items. We have a lot of people joining today, so everyone's audio will be muted to avoid background interference. If you do have questions, feel free to post your questions in the Q&A during the presentation. And at the end of the presentation, we'll walk through a few of your questions through a live section. After the webinar, we will put together a list of all the participant questions posted along with responses from our Energy Code technical team. And then we'll send this out as a supporting resource to everyone who registered today. If you experience any technical difficulties, please communicate this to us via chat as well, and we'll do our best to resolve whatever issues that you have. This webinar is being recorded and will be posted to our WSEC website soon. Okay, let's get started. First of all, I'd like to begin and introduce you a little bit about who ETC is. Our team provides training and technical support for the commercial provisions of the Washington State Energy Code. If you need support for the single-family residential requirements of the code, please contact the Washington State Energy Extension team. Our support includes on-call technical support through three different avenues. First of all, we man a telephone hotline so you can reach us directly at area code 360-539-5300. You could also email us through our website or directly at com.techsupport@waenergycodes.com. Or you can complete an online form on our website at www.waenergycodes.com that we will receive directly. We also provide classroom and webinar training. Due to the current circumstances with COVID, our training this year has been in the webinar format, but hopefully we'll get this past us and be able to offer in-classroom training soon. We administer the new technical support compliance documentation web tool, as long as supporting the compliance forms. My name is Duane Lewellen. As I mentioned earlier, I'm on the left there. Many of you know Lisa Rosenow. Lisa's been involved with code support now for about 4 code cycles, and our resident electrical engineer is Chris Haas that helps us out on lighting and electrical issues in the code. Also, we'd like to acknowledge the Northwest Energy Efficiency Alliance for their generous support of energy codes throughout the Pacific Northwest. NEA is an alliance of utilities that pools resources and shares risks to transform the market for energy efficiency to the benefit of consumers here in the Northwest. The NEA Codes program supports development and adoption of energy codes throughout the Pacific Northwest and makes today's training possible. So I highly encourage that you visit the NEA website and also their code work to see what's going on around the Pacific Northwest. Thank you, NEA. So let's talk a little bit about our education opportunities for this year. Our online training series started out with episode 1 in May. We covered building envelope. Episode 2, mechanical systems part 1, was completed on May 20th. Episode 3, introduction to TSPR, was on June 3rd. That training is being administered and provided by the Integrated Design Lab at University of Washington and Pacific Northwest National Labs. Episode 3 will be repeated again on August 5th. We've had completed episode 4, Mechanical Systems Part 2, on June 24th, and we completed episode 5, Lighting and Electrical Systems, on July 15th. You'll notice that there's a little video screen next to several of these. That means that those episodes are available for on-demand viewing on our website. So if you were unable to attend those previous episodes, you can view those at your leisure from our website under our Training and Resources tab. Today we're covering service water heating and refrigeration systems, and then finally we'll be covering episode 7. The last episode in our series will be additional efficiency options on August 12th. I do want to talk a little bit about the status of the 2018 Washington State Energy Code. The original adoption date was July 1, 2020, but due to COVID, the effective date has been postponed until February 1st, 2021. You'll be able to download the Energy Code. If you need a copy of the 2018 Washington State Energy Code, you can download that directly from the State Building Code website, Council website. I do want to point out that there is a second edition out that's errata from the first edition, so to make sure that you've got the most current edition, please download the second edition. A little mention about code interpretations. The State Building Code Council does provide specific code interpretations. There's already been interpretations on the 2018 Washington State Energy Code, so you might want to check those and download that out. Those code interpretations are initiated by building officials for specific jurisdictions. They are non-binding in nature, they're just advisory, so you may want to go check that out. As far as ETC is concerned, our interpretations represent our unofficial interpretations of code intent. Our technical support team is not an affiliate, nor do we speak for the Washington State Building Code Council. Our interpretations and technical support is advisory only and non-binding. We do have a lot of experience, so we hope that our interpretations and guidance is helpful. So, what's on the agenda for today? First of all, we'll talk about some minimum performance updates to the minimum performance requirements for service water heating systems. Then we'll move on to a whole new section, or a section that's been completely revised for high input water heating systems. Single and multiple riser hot water circulation systems. Metering for domestic hot water systems. Additional efficiency options for service water heating systems. Insulation requirements for walk-in coolers and freezers. New performance standards for walk-in coolers and freezers less than 300 square feet in size. And then finally, after our presentation today, we'll have a live Q&A session to answer any questions that comes up. Again, I remind anybody that has questions that come up during the presentation to go ahead and respond to the Q&A section, and we will summarize those at the end of the presentation today. So let's start off talking about the updates to service water heating systems. So one thing that you're going to want to check out is updates to Table C404.2. Table C404.2 lists the minimum performance requirements for water heating equipment. There have been multiple changes in increasing the energy factor requirements for electric and gas-fired water heaters. So you're going to want to review that table. Those are in line with changes that were made at the federal level through the Department of Energy, so it's consistent with federal standards and ASHRAE standard 90.1. Energy factor is a method of determining the energy efficiency of a hot water heating system. It includes not only efficiency of the fuel source or the heating type, but also standby losses, for example, in tank-fired systems. The new standards do include both tank type and instantaneous water heaters, so if you're specifying or reviewing tankless water heaters, there's also been updates to those energy factors. And then finally, worth noting is that gas and oil-fired pool heating equipment efficiency has increased from 78% to 82% thermal efficiency. Another change that's been made to the performance of water heaters is for new electric type water heaters, tank type water heaters, greater than 75 gallons, but less than 120 gallons in storage capacity. If you specify or plan to install an electric water heater that meets this criteria, that water heater needs to be grid enabled. So what is grid enabled? Grid enabled is a water heater that's equipped with a communication port to enable demand response participation. In other words, and this is uncommon in the Pacific Northwest, but very common in other parts of the country, when you have a grid-enabled water heater during times of peak demand on our electrical grid, the utility may be able to shut your electric elements off. so that you just use the stored water capacity. This reduces in lower demand on the electric grid and keeps your rates low. Demand response programs are fairly common and popular in other parts of the United States, but they're just starting to show up here in the Pacific Northwest, and this will allow electric utilities to manage the demand on the grid. You have this 75 to 120 gallons of water stored up in your water heater, so you can go a while without having the elements to come on. So this provides some added capacity for the utilities without affecting your production or use of hot water at the time. So an area that's been revised in the 2018 Washington State Energy Code is high input water heating equipment. There's two classifications of high input water heating. There's for occupancies other than Group R, and then there's separate requirements for occupancies that are Group R. So we're going to take a look at each one of those differently. So high input water heating for other than Group R occupancy applies to systems with a combined input rating installed in a building greater than 1 million BTU an hour, or equivalent 283 kW. It applies to new buildings only, although I'll mention maybe perhaps some alterations where this could affect you. And these occupancies other than Group R would include medical, hospital, restaurants, grocery, cafeteria, exercise facilities, and labs. So what are the requirements? If it's an other than Group R occupancy and they meet the requirements for a high input water heating system, if it's an electric fuel system, then you shall use a heat pump with a rated COP of 2.0 or greater. If it's a fossil fuel system, you have to use a rated thermal equipment with a rated thermal efficiency not less than 90%. So again, electric system, heat pump with a coefficient of performance 2.0 or greater. If it's a fossil fuel system, high efficiency greater than 90%, not less than 90%. Now there are exceptions for other than Group R occupancy worth noting. If 25% or more of the annual hot water is provided by renewable or site recovered energy, you're exempt from that requirement. If you have a hot water heat exchanger using district steam or hot water. Heaters used to boost hot water temperature for equipment use, for example, in a restaurant or commercial kitchen, the booster water heater. And then finally, electric resistance heating is acceptable as an auxiliary heat capacity in heat pump type systems, provided that it is locked out above 32 degrees Fahrenheit. So you can have a heat pump system that still includes electric resistance backup, provided that that backup is locked out when the outside air temperature is above 32 degrees. So for Group R1 and Group R2 occupancies, this applies to systems serving R1 or R2 with greater than 1 million BTUH or 283 kW. It applies again to new buildings only, and these occupancies include hotels, motels, multifamily, dormitories, and mixed-use buildings where you might have Group R1 or 2 in the building along with some other occupancy. So what is the requirement? The requirement is that 25% of the annual water heating energy shall be provided by any combination of the following heating. It shall be provided by either renewable energy generated on-site that is not being used to satisfy other requirements of the code, or site recovered energy that is not being used to satisfy other requirements of the code. For example, you cannot use the service water heating heat recovery requirements of C403.9.2 to also meet this requirement. So this 25% requirement is in addition to any other water heating energy recovery requirements that are in the code. Again, there are exceptions for this requirement depending on the type of hot water system that's in the building. If you have single electric water heaters in the building in your Group R1 or Group R2 building, if you install electric water heaters with an input capacity weighted efficiency 5% better than code minimum, you're exempt from that requirement. If you have fossil fuel tank type water heaters, that are 5% better than code minimum, you can also be exempt from that requirement. If you have commercial heat pump water heaters with a rated COP of 2.0 or higher and auxiliary electric or fossil fuel locked out above 32 degrees, you can also be exempt from this requirement. Last couple of examples. If you've got fossil fuel water heaters with incapacity weighted thermal efficiency of not less than 90%. And then finally, you're exempt if you have hot water heat exchangers from a district utility steam or hot water system. And so those are the exemptions from that 25% site recovered or renewable energy requirement for Group R1 and Group R2 occupancies for high input service water heating systems. Note it's okay to use a combined input capacity weighted average equipment efficiency. What that means is that not all of your water heating equipment would need to meet these efficiency requirements to meet this exception. For example, you could have some of your electric water heaters just meet the minimum requirements, but some meet greater than 5% of the minimum requirements. So as long as the weighted average efficiency of the equipment meets that 5% requirement, you're deemed to comply with this exception. One small minor change worth noting is that piping insulation, hot water piping that's part of the final run out to the fixture and is not part of the heated water circulation system, does not need to be insulated. So this was always problematic in the field of where does the insulation requirement start and where does it stop. The previous code required that the insulation run continuous all the way to the stop valve of the fixture. This has been modified now, so those runouts, as I've shown here, this is a simple single riser recirculation system. So those runouts to the lavatory, shower, kitchen sink, and dishwasher do not need to be insulated. However, the recirculation system back to the water heater does need to be insulated. So it's a minor change, but it's helpful to get some clarification of what's acceptable. So moving on for some additional changes in service water heating. The language around circulating water heating systems has been simplified, which is a helpful change. So if you have a single riser, simple circulation system with a pump and a recirculation line, you shall have controls to turn the pump off when the hot water is not required, either an automatic time switch or an aquastat. You don't need both. You just need to have some sort of automatic control that turns that pump off when there's no demand for hot water. In addition, controls shall be provided with a manual switch so that you can turn off the water heater, the circulating pump, during extended periods when hot water is not required. You know, in most commercial buildings, there's not necessarily extended period, but I'm thinking here in the current COVID requirement, it would be handy to have a switch to turn off the circulation pump if the building or the office space is unoccupied. If you have a multiple riser circulation system, for example, in R2, a multifamily building with a central water heating system, or in a hotel motel where you have multiple risers distributing hot water to the fixtures in the building, you again need to have controls that will turn the pump off during extended periods when hot water is not required. That can either be a time clock or aquastat, as we mentioned earlier. But you also need to include the means for balancing the flow rate through each riser or piping zone. Now, this is fairly common practice, but the code has added this language that you need to have a method of balancing the flow through each riser. Another change on the service water heating system is domestic hot water metering. That the scope has been expanded to include occupancies other than Group R2 in the 2015 Washington State Energy Code. This requirement was only for Group R2 occupancies, and that remains the same. Each individual dwelling unit with central hot water systems shall be provided with a domestic hot water meter to allow for billing based on usage within that dwelling unit. That requirement, though, has been extended to dwelling units in other than Group R2 occupancies, so either individual dwelling units or live-work units They're exempt from individual hot water metering if you provide sub-metering provided for the following end uses. So dwelling units, sleeping units, commercial kitchens, and central laundry. So if you do have dwelling units in occupancies other than group R2, you need to provide sub-metering for those dwelling units, but it doesn't have to be each individual dwelling unit. So if you had, for example, sleeping units in a fire station, you would only need to, and they had individual restrooms, for example, or even dwelling units in a fire station, you would just need to sub-meter the hot water supply to that group of dwelling units. You would not have to sub-meter each individual dwelling unit. Another change in the 2018 Washington State Energy Code refers to service water pressure boosting systems. So there's new requirements for pressure boosting systems on service water heating systems serving buildings. They shall be installed with pressure sensors to vary speed or startup pumps. They shall be installed with devices for the purpose of reducing the pressure of all, it's installed with no devices for the purpose of reducing the pressure of all the water supplied to the system, except safety devices. This is important. You can still have balancing valves or circuit centers on branch piping serving different risers or areas of the building, but you shall not have a pressure reducing device downstream of the pump that regulates the water pressure for all of the water supplied by the system. Pumps shall not operate when there is no service water flow except to fill the pressure tanks. And finally, pump motors 7.5 horsepower or greater shall be provided with variable flow capacity. I think you would agree these are all good practice when it comes to service water pressure boosting systems, and now we've added that scope and that good practice to the Washington State Energy Code. So a little bit about the service water heating additional efficiency credits. I know that we will be providing another episode, our final episode coming up here in the next couple of weeks on additional efficiency credits, but I just want to cover them briefly in today's presentation. So around service water heating, there are 2 efficiency credits for service water heating systems. Credit number 8 is for high efficiency service water systems. Credit number 9 is for high performance service water heating systems in multifamily buildings. You will see that credit 8 is available or can be applied to occupancies including group R1, R2, and all other occupancies with credit points ranging from 4 in group R1 all the way to 8 in other occupancies. And then for credit 9, you'll see that it can apply to group R1 and group R2 only. So let's look at each one of those in a little bit more detail. So high efficiency service water heating credit number 8. First of all, the scope for that credit would apply to group R1 buildings, boarding houses, hotels, motels. Group I2, institutional buildings, hospitals, psychiatric hospitals, and nursing homes. Group A2, restaurants, banquet halls, buildings containing food prep areas. Group F, buildings, laundries. Group R2, as we mentioned, multifamily. Group A3, health clubs and spas. And also buildings where the service water heating load is 10% or more of the total building load in the building. Credit is limited to these occupancies types where water heating equipment has to serve 90% of the whole building or tenant space. So if the water heating systems serve less than 90%, you're not eligible for this credit. Now do note that that's for the whole building or tenant. So if you have a tenant in your building and this water heating serves 90% of the tenant space, then you would be eligible for this credit. So what is the requirement? So for credit number 8, not less than 60% of the annual hot water use or 100% for water-cooled buildings. So if you have water-cooled HVAC equipment, it shall be 100%. Be provided by one or more of the following. Either a heat pump system with a minimum COP of 3.0. So we saw earlier that in our high input water heating systems, the minimum COP was 2, but in the additional efficiency credit option, it's 3. Or waste heat recovery, in addition to other code requirements. So if there's depending on the type of building, if there's an energy recovery requirement in the code, then this must be in addition to that requirement, or on-site renewable energy water system. So not less than 60% of the annual hot water or 100% of the water-cooled buildings shall be provided by one of these options to meet that credit. For credit number 9, high-performance water heating in group R1 and R2 buildings, again, the water heating system has to supply the whole building, the addition or tenant space with not less than 90% of the conditioned floor area. And then to meet that credit, not less than 90% of the service water heating requirement energy use has to be provided by a heat pump system with a minimum COP of 3.0. I just want to note that this additional efficiency credit is allowed to be taken in addition to credit number 8. So for example, if you meet the 90% threshold for a heat pump COP of 3.0 or greater, you will earn the number 8 credit points, which is 5, and then these credit points, which is 8, and meet the entire credit threshold for the entire building. So there's an incentive there for buildings of group R1 and R2 buildings where they could meet their entire additional efficiency credit option with these service water heating additional points. And then lastly, a little bit about existing buildings and service water heating systems. Alterations to existing buildings, so service water heatings in existing buildings, for example, water heater replacement, boiler replacements, storage tank replacement, circulation pump replacement, new piping, shall comply with the 2018 WSEC requirements. So if you touch it, you need to meet the code. If you add new piping, it needs to be insulated to the code. In addition, the following changes in occupancy or use shall be brought into full compliance with the code, including the high input water heating requirement as applicable and the additional efficiency credit requirements. And this would include changes for group F, S, or U occupancy to an other occupancy, or any space that's converted to a group R dwelling unit from another use. So keep that in mind if you've got existing buildings. Specifically, what comes to mind recently is I had a project which was a storage building, so group S occupancy, and they were converting, interestingly enough, they were converting this building to a group R2 occupancy. So change of use, they would need to fully comply with the Washington State Energy Code requirements. Depending on how they provide hot water, they may need to require with the high input water heating requirements and the additional efficiency credit options. And then finally, on service water heating commissioning. Commissioning is required for all service water heating systems with an installed capacity of 200,000 BTUH or greater. And this applies to both new and existing buildings. So if you're replacing a service water heating system in an existing building and the capacity is greater than 200,000 BTU, commissioning is required. What is in the scope of the commissioning? Well, first of all, swimming pools and permanent spas require commissioning in all cases, regardless of heating equipment size. The scope of commissioning includes functional testing of controls and set points, and finally, completion of and submittal of the commissioning checklist, which you can find a copy of in the Washington State Energy Code. So we're going to move on from service water heating to refrigeration systems. So there's been some changes in the requirements for walk-in coolers and freezers. There are new Department of Energy standards for walk-in coolers and walk-in freezers that went into effect on 1/1/2020 for medium temperature systems and on July 1st, 2020 for low temperature systems. And those changes and energy standards, those new energy standards have been incorporated into the 2018 WSEC. The scope includes assembled and site-constructed walk-in coolers and freezers less than 3,000 square feet area. If you have a walk-in cooler or freezer greater than 3,000 square feet, you would follow the prescriptive requirements in the code. Compliance is based on tested component and or system performance. So this is a general trend in the code where rather than looking at the performance of individual components, this standard looks at the performance of individual systems and components in the system. And these DOE standards are expected to reduce energy consumption of walk-in coolers and freezers by 20 to 40%. So I've thrown out some tables here. The standards start off with, begin with the requirements for walk-in cooler, freezers, and doors. So there's a new table. So if you have a walk-in cooler, freezer less than 3,000 square feet, then your cooler and freezer doors have to meet these minimum standards. Now, if it's a display door and a medium temperature door, it has to meet a maximum energy consumption value or kilowatt hour per day based on the area of the door and the calculation in the table. Being that this is a federal standard, this data should be labeled on the door, or you should be able to get this data directly from the manufacturer. In researching some of these requirements, I noticed most manufacturers of walk-in coolers and freezers are already on board with these new DOE standards and are labeling their equipment accordingly. If you have passage doors, non-display doors, then depending on the temperature and the capacity of the system, you have another, and the size of the door, you have another maximum energy consumption value in kilowatt hour per day. So find your door, find the value, and then you can determine whether the door meets that standard. Again, the manufacturers are beginning to label their doors or publish their performance data on their doors, so this should be easy to verify. Note that this is a maximum energy usage, so the proposed doors need to be equal to or less than these values. For the system performance for the compressor and condensing unit, we also have requirements, and this looks at the performance of the evaporator fans and evaporator coils within the walk-in cooler, and then the condensing unit and the compressor that's external to the walk-in cooler. So there's a new performance criteria called AWEP, which is maximum annual kilowatt hour energy factor, or AWEF, excuse me, and that's in a BTUH per watt hour value. So again, depending on whether you have a dedicated condensing unit, what the temperature is, whether it's a system located inside the building enclosure or outside the building enclosure, these are the minimum efficiency values. So this would be similar to a SEER rating on an air conditioning unit, for example. So this is an annual efficiency value for the compressor, condensing units, and evaporator systems for walk-in coolers and freezers. And as I mentioned, the energy efficiency measures for these systems would include variable capacity compressors, oversized evaporator and condenser coils, ECM motors on evaporator fans and condenser fans. Again, achieving anywhere from a 20 to 40% reduction in energy use for these systems. Now, commissioning of refrigeration systems is required. Self-contained refrigeration systems are exempt from commissioning, so if it's a self-contained display case, that is exempt. All other systems greater than 20 tons cooling capacity, and again, the code is silent on this, but our understanding of intent is if there's more than 20 tons of refrigeration cooling capacity, then commissioning is required. And you would need to verify the proper operation of the systems. Now this, again, the scope would be walk-in coolers, walk-in freezers, refrigerated warehouse coolers, and refrigerated warehouse freezers. So just to wrap up today's session, I do want to talk about some of the resources that are available to help you with compliance for service water heating and commercial systems. As mentioned earlier, we have a technical support website at www.waenergycodes.com. I encourage everybody to visit the website. We have a lot of resources that are available for service water heating systems and refrigeration systems, so please check that out. Within that website, we have some integrated education. We have frequently asked questions section that will be searchable. So we'll have questions up there for service water heating systems and refrigeration systems. It is searchable, so you'll be able to determine that. We will also have unique searchable ask questions for both the 2015 and 2018 Washington State Energy Code. We have integrated education. So we have learning moments. So as you input information about the scope of the systems, in there we have pop-up education to help explain, or essentially integrated help. So as you're completing the forms, you can click on the little information icon and get an explanation of what we're looking for in terms of information. Now for our refrigeration and service water heating, we will not have specific consoles for you to input heating equipment efficiencies and capacities. However, we will have a smart checklist. So if service water heating equipment and refrigeration equipment is included in the scope of the project or the permit, and you check those boxes off on our project information section, you will be provided with a specific requirements checklist. Here's an example of it here that will detail what those requirements that you need to meet will be, what you need to have on your drawings. And this will be a great quality assurance tool for you to verify that you're meeting all of the requirements for service water heating systems and refrigeration systems. So by all means, go check out our website at www.waenergycodes.com. Become a member. You do need to be a member to access our tools and resources, and this will be available. This is available now to assist you with service water heating and refrigeration systems. And then finally, talking about what's coming up in our training series. Our next training will be on August 5th. That will be a repeat of episode 3, which is Introduction to TSPR. On August 5th. Again, this is being provided by the University of Washington Integrated Design Lab and Pacific Northwest National Labs. And then finally, the last series in our training, episode 7, will be on additional efficiency options, which is scheduled for August 12th. So note that on your calendar. Our training schedule is also posted on our website, and that's where you can register for these training sessions. So again, another reason to go to our website and register for upcoming training. With that, I want to thank everybody for joining our webinar today. We'll be transferring to our continuing to our Q&A session. So if you had questions during the training, make sure you get those all in there. It's going to take us here just a minute to transition to our live Q&A session. I appreciate your attendance today, and I'll be talking to you real soon here.
Hi, this is Lisa, joining the webinar here via audio. Duane,
I can hear you. Can you hear me?
I can. Great. Well, that was really, really helpful. Thanks, Duane, for putting all that information together. Lots of interesting changes for the service water heating section of the Energy Code. We had quite a few questions roll in, so I'm just going to go ahead and start from the top, the one with the most votes. And again, thanks everybody using the upvote feature in Big Marker. That's very helpful to see what are the topics of most interest to everybody. So Derek Archer submitted several questions. So his first one here is, how do I calculate energy factor for a water heater with an outside mounted heat pump water heater that circulates water to a storage tank, and the storage tank has an electric backup element?
That is a good question, because the energy factor is a DOE standard, and I'm sure there are specific conditions, just like an AHRI conditions. And I don't know if it includes a heater separate from the storage tank with the heater installed outside.
Mm-hmm.
Energy factor is a combination of the thermal efficiency of the heater plus the standby losses. So you could kind of get there, but if it's a system that's not regulated by the DOE or other standards, then the minimum energy factor would not be required.
Yeah, that's a good point. And also with regard, I mean, it's a very good point when you talk about the distinction between the federal standards and then any additional requirements that are in the energy code. That's a really good point, and that a lot of the efficiency requirements, or most of them in the code, are federal level. So keep that in mind. Okay, so Derek Archer has another question. It says, has there been evaluations as to how demand response may promote Legionella hazards if heating is restricted? It seems like a potential health liability. We've heard that one. That one's come up a few times.
It's primarily come up in terms of the hot water heating set point, but my reply to that is this language for demand response on the larger electric tank type water heaters is actually straight out of the IECC, which is vetted at the national level by the ICC. And I would assume if there was a conflict with the International Plumbing Code or any other health and standard codes, including NSF, that would have been addressed.
Mm-hmm.
So I haven't, I've heard about Legionella in terms of set points for water heating systems, but I haven't heard about it from a demand response. The other thing to keep in mind that demand response generally is a relatively short-term event, an hour or less. So the water heater is not going to be turned off, or the heating elements anyway are not going to be turned off or overridden for a very long time. So I given the current installation requirements for water heaters, I don't see a lot of losses occurring. And so that may, but if there is something that there is conflict, then other codes would supersede the energy code, whether that's a plumbing code issue, a building code issue, or if there's some other health and standard code, that would take precedence over the energy code standard.
Mm-hmm. Yeah, that's a great point. I'm gonna actually jump to another one of Derek's questions, and then we'll loop back, because we do have several questions with regards to existing building retrofits. So we'll do all those together. So Derek asked another specific question. He says, I don't understand the hot water circulation for single risers. If the hot water isn't required and the pump turns off, the loop cools down, and then someone turns on the hot water and has to wait forever for hot water. It just seems like a waste of water and makes a recirculation system a moot point. I hope I'm missing something here.
So yeah, that's been a common argument for a long time. So two things. One is that the code doesn't require that you turn off the pump during occupied hours. It only requires that you turn off the circulation pump during unoccupied hours. So, and that's actually different from the previous code required that you had a time schedule and an aquastat, which would have turned the pump off. So you can just use a timer and just not circulate the pump during unoccupied hours, the assumption nobody's demanding water and you don't waste the water. If you do use an aquastat, the code is clear that the aquastat would only cycle the pump back on. So when there's no demand for water, the pump is off. And then if the temperature drops 10 degrees below the set point, the pump would come back on. So it would cycle the pump on and off. I would say the other issue addressing the water waste is the pipe sizing requirements. I didn't really cover that because that was established in the 2015. There's been a lot of heartburn over the size of runouts to fixtures, but there's been a lot of effort to reduce the volume of water in the runouts to fixtures so that if it does cool down, the water waste is considerably less. There was not a change that continued through to the 2018 code, but that was a change made in the 2015 code to reduce that waste of water when you initially open a fixture.
Yeah, that's a great point. And also, we do keep in mind too that the surface water heating section of the code, it does, it handles the energy side, but it also deals with water use indirectly. So that's a great point. Okay, so Marcy Carr, let's see, she has a question. Here we go about combined heat and power. So for combined heat and power, CHP. Does that count as renewable? And CHP allows us to reduce the demand on the traditional water heater by as much as 100%, depending on electrical demand on the generator.
Yeah, so I would not, I do not believe combined heat and power, assuming that it's a fossil fuel source, is renewable energy. However, it is energy recovery or heat recovery, because that you're generating electricity, I assume, and then you're recovering the exhaust from that process heat, if you will, to serve a heating demand, whether that's surface water heating or heating the swimming pool or heating the building. So I wouldn't consider it renewable. I would consider it energy recovery, though.
Yeah, I would agree with that assessment. Okay, so Derek has a question. For heat pump water heater COP, what ambient condition is that rated at?
So there's two different things there. If it's a tank type heat pump water heater that's regulated under the efficiency tables with an energy factor, there are very specific conditions. If it's a commercial type heat pump water heater, the code does define what those conditions are for the COP. I'm trying to look it up right here real quick. With an air temperature of 60 degrees or less. So 60-degree outdoor air temperature for those commercial, what we'll call them split system type water heaters.
Okay, that's helpful. So let's see, Derek has a question. If we replace an electric tank type water heater that fails with age, do we have to bring the entire hot water system fully up to code?
That's a good question. I would say no. That it's not the intent of the code for existing buildings to require full compliance. Now, the new water heater has to meet the code minimum requirements for energy factor, but the entire system, if it's over 1 million BTU an hour or whatever, doesn't have to meet the full requirements of the code.
Yeah, I agree with that, and the easy way to think about it is that if you touch it, you have to bring it up to the current code rule, right? And if you think about that, that's the only part of the system that you do have to worry about making sure it meets the current code. However, if there are controls requirements associated with the new equipment, then you would have to meet those control requirements, and so there might be some additional requirements that would kick in associated with whatever you're replacing. But that's a great question. And actually, I'm going to scroll back up because there was another one about existing buildings from Jacqueline Baker. She says, what counts as new piping on an existing building? What if you're extending piping to a new fixture?
So if you're adding piping or replacing piping, that would require insulation except the final run out to the fixture, or if it's recirculation piping. So the way I interpret the code, if it's just like what Lisa just stated. If it's new, it needs to comply. But I mentioned during the presentation that runouts, the final run out to the fixture, does not need to be insulated unless it's as long as it's not recirculation piping.
Okay. So Hoyt has a question. He says, why gas and oil-fired water heaters has an upper limit for thermal efficiency for a performance update?
Well, that is, you can exceed that. So I'm not quite sure, Hoyt, I understand the question. I think that's the minimum efficiency, and it is perfectly acceptable to exceed that efficiency. Lisa, do you have any, do you know perhaps what Hoyt was getting at that?
I'm not sure. So Hoyt, if you've got additional question or feel free to post that into the Q&A, we'll make sure we tackle the rest of it.
I would say all of the efficiencies in the table C404 are minimums. So it is perfectly acceptable to exceed those, and then through the additional efficiency credits, you may even, depending on the occupancy, receive an additional efficiency credit for exceeding those.
Exactly. Okay, so Marty Gillis has some questions. She asks, how are electric water heaters run on a loop treated regarding this utility port? Is it the same as a non, circulating loop system? I think she's referring to circulation systems.
So, hi, Marty. There is no requirement that you do a circulation system. So the code doesn't require that you put in a circulation system. So if you have an individual water heater, above the restroom stack in a small commercial building, and it doesn't have a circulation system, that's perfectly acceptable. And that's probably fairly typical when you have individual tank type water heaters for residential. Only if you provide a circulation system or a heat maintenance system with like electric heat tape does it need to be automatically controlled somehow.
And then she had another question, and I think that you answered this one in a later slide, but we'll go ahead and just cover it again to make sure we tackle this. So she asked, when you say that R1 and R2 water heating requirements apply to new buildings only, does this mean existing change of use buildings are not included?
That's a great question. And putting together the slide deck, I tended to look at that. If it's a change of use from FS or U to other than FS or U, you have to fully comply. And if your change of use is from something other than R1 or R2 to R1 or R2, and you have high input service water heating, your total capacity of your water heating system is greater than 1 million BTU, you would need to comply with the service water heating. That's my general intent. Although if you look at the language in the specific language says new buildings, but then we have chapter 5 that basically says that changes of use have to fully comply. So, I'm kind of making my own judgment call here on intent. And an example I think I used in the presentation recently was the conversion of a Group S storage, mini storage facility to Group R, where they were going to convert it from Group S to Group R. And they would have to fully comply, not only with the water heating requirements, but also envelope and mechanical. And so, I don't know, Lisa, do you have any insight on the code saying new buildings specifically in the language, but then C50, existing, changes of use and occupancy?
Yeah, that's a good point. And I think that to the letter, if it says new buildings, I think you read it as new buildings. I mean, I think that's a fair assessment. However, when you look at chapter 5, and there are requirements over there that talk about, if you're doing this change, and actually I'm going to get into the weeds just a tiny bit. It only applies if you have an existing building, if you're going from a change of occupancy or a change of space conditioning. Those are the two triggers. It actually doesn't say change of use. And we get a lot of questions about that. The only part of that code section that applies to change of use are lighting power allowances. And so we're really only talking about change of occupancy. But for this particular requirement, since it says new buildings, which is kind of unusual in the code, I think that it would be fair to say, well, if it says new buildings, then it means just that, just new buildings. So, but that's our interpretation. Someone else might have a different opinion. Okay, we've got a couple more. So Todd Williams asked, who's verifying refrigeration commissioning?
Thank you, Todd. That's a great question. Refrigeration systems, commercial refrigeration systems have typically been done by a separate kitchen equipment contractor, refrigeration contractor, generally not provided by or designed by the architects or mechanical or electrical. But it is within the scope of work. And so my feeling is that the local jurisdiction should be verifying commissioning of those refrigeration systems. It's included in the scope of the permit.
Exactly. And the way they can do that is, at plan review, taking a look at what they've got in their plans and their specs to make sure that they're requiring commissioning of those systems in their plans. And then also during field inspection to be looking for that commissioning checklist.
Yep.
So that's a way that the jurisdiction can address that. Okay, so over in chat, we've got a few more questions. Randy Stabno asks, are thermostatic valves an acceptable means of balancing for multiple branch recirculating systems?
Yes, I would say that they are. Downstream of, so on the individual branches, whether it's a thermostatic valve or a circuit set or balancing flow control valve, that would be acceptable. It's just that what's not acceptable is to have a valve that restricts all of the water heating demand post, or that's on pressure boosting systems. But I would think if you've got some means of balancing individual branches on multi-riser, whether it's thermostatic or flow, that would be acceptable.
Yeah, that's I would agree with that. So Marty has another question about commissioning. This is a good one. Are there commissioning credentials needed? It's outside the scope of the presentation today, but it's worth noting. So
yeah,
go ahead.
it is. It is. So the short answer to that is yes. The code has specific requirements for a commissioning credential. Per ASTM. I can't cite the number off the top of my head, but there's probably about a half a dozen different credentials out there for commissioning. So that's one. The other thing is that the commissioning provider needs to be independent of the installing or designing contractor. If you are part of the design team, you can still commission, or the construction team, you can still commission the project, but you have to submit a conflict of interest statement. For example, a large contractor may have a separate division for just commissioning. So they're not involved with construction, they're not involved with design, etc. And that's perfectly acceptable for them to commission their own work, provided they complete this conflict of interest statement.
Yeah. So thanks. That was a super fast presentation about commissioning. So thanks for the quick summary. Okay, couple more. So Eric Thompson asks, can a small dedicated water heater for a restaurant be turned off based on grid demand monitoring?
I don't see, if it's greater than 75 gallons and less than 120 gallons, and it's an electric resistance water heater. Yes.
Okay.
Now, I would say that I would think it would be acceptable. One of the issues about demand response in the Pacific Northwest, which is different, or at least in Washington State, which is different than other area of the country, is that our peak demands occur on a cold day in the morning. When everybody is showering and turning the heat on after it's 20 degrees outside, and all the electric heat and the heat pumps and the electric water heaters are heating up because somebody's taking a shower. And our demand peaks typically occur at a time that's not going to be coincidental with a restaurant's peak use, as opposed to Southern California, where it's late in the afternoon and the restaurant may be in work. So I would think that if you are on a demand response program, the only time you're going to be curtailed, at least in the Pacific Northwest, is on a really cold day in the winter at 6 o'clock in the morning.
Agreed. Okay, let's see. We've got enough time for probably just one more. So Carlos Herrera has a question regarding documentation. So it says, he says here, is there a hot water usage form available to demonstrate 60 to 90% hot water usage for credits 8 and 9?
That is a very good question, because there is not a form for putting together consumption. There are a lot of guides for sizing of water systems based on peak demand over 1, 2, and 3 hour periods. But there's not. Now, there are really good rules of thumb out there, at least for multifamily, on hot water use per person per day. and total water use per person per day. So I think there's a lot of really good empirical data for that you could extrapolate annual hot water BTU for multifamily, group R1, group R2, basically. Hotel motel, probably a little bit more difficult, and other occupancies even more. So it's just going to be an educated guess calculation for what that annual hot water use would be.
Yep. Okay, well, we're right at 4 o'clock, so I think we got through most of them. Any supporting comments that came through, we'll make sure that we address those. We are putting together these lists. There's a lot of them to put together for all these webinars, but we will be posting them here soon. But thanks, Duane. Great presentation, and thanks everybody for all the excellent questions. You know, that part was really great. It really supplements the presentation, and we appreciate everyone's contribution.
Hey, Lisa, do we want to mention this will be posted on our website for on-demand viewing here shortly?
Yeah, actually, we'll make sure this gets posted in the next few days. So we're in good shape for that. So for anybody, if you know of anybody who didn't get a chance to watch the webinar today, go to the WSEC commercial website, and it will be posted there for on-demand viewing.
Great. Okay. Thanks, everybody.
Thanks, everyone. Have a great day.